Hello everyone and welcome to one new episode of Golang Cafe, and today we're going to talk about the http trace package. The http trace package allows us to analyze various events that occur whenever we execute an HTTP request with the Go client. So whenever we attempt to send an HTTP request to a HTTP server using the Go programming language, the HTTP trace package allows us to inspect and monitor the various steps that are involved whenever we execute a HTTP request. And today we're going to see in depth and in details how we can use that to monitor the performance of our requests, and we can troubleshoot also all the events that are happening within our HTTP requests. It is available from Go 1.7, so should be available already this time of recording. And we can quickly see the structure of the documentation, the structure of the HTTP trace package by just going with our usual Godoc HTTP trace. And you will see that the documentation is short yet very exhaustive, and it's very concise and very clear on what types we can use. The most important type, if you have to take away anything from this, it's the client trace. So the client trace is what is going to be used to instruct our HTTP client to track down and to monitor the determined steps of our HTTP request. And we can create the client trace just by initializing the struct and then passing it into our request by using the with client trace, which is going to return a context. So it's created directly, invoking the struct, initializing the struct, and then we need to attach it to a context. Once it's attached to a context, we can then use the context and pass it down to our request, and is then going to be used by our HTTP client in Go to monitor all of the definition specified in the trace object. Here you can see some objects that we are going to see later on. Those are specific for some of the steps that we are going to see in the client trace. But the most important thing that you need to remember is just the client trace one. So if we just go quickly and check the documentation for client trace, we see that it's a struct. It has a bunch of exported fields, and all of those exported fields represent a specific step and a specific event on the HTTP request that the HTTP client does on our behalf. So those are functions. It means that each time an event occurs, those functions will be invoked. The order in which the function is specified in the struct doesn't necessarily imply that those functions are going to be executed in this order in our HTTP request. But the exception is for the get connection, which is going to be the first one executed usually. It's the hook, also called hook. So all of those functions can be called hook because you can effectively think of them as hooks that are going to be invoked whenever a certain event occurs. The get connection is the first one, is the most basic one. Is whenever we start whenever the client is about to start the connection, is about to retrieve the connection from a pool, from a cached connection pool, or is about to create a new connection. We are going to talk about the cache connections and cache connection pools in a moment as well, but this is going to be the first event that happens in our HTTP request lifecycle. The GOT connection is right after we have created the TCP connection, so right after we have done all of the setup to effectively create the connection. The put idle connection is only used on a specific scenario, and it happens when you want to reuse the connection. This is also known as HTTP persistent connection, and it's not something specific to Go, but it's a concept that is already known in HTTP version 1. Doesn't apply for HTTP version 2 because this is already by default. So in HTTP version 2 already the connection reused by default. But in version 1 you may have seen already the header keep alive, the keep alive header sent by the client to the server and vice versa, and that's going to tell the server to reuse a certain TCP connection because the client is going to send the new requests eventually afterwards. So we don't have to establish the connection from scratch, but just send the new data over the same connection. So this is going to be called right after the first connection is sent, usually, and the and the Go client is going to put the connection into a cache, into a pool connection, a pool of connections that are going to be reused later. And if we ever going to call an HTTP request for an host that we already used, and then we're going to find and we're going to use the idle connection, so the pooled cached connection. And this is the method that's going to be invoked whenever the client puts the connection aside on the cache. So this is useful for a specific reason, for the reason that it's useful for us to know if a connection has been cached, when it has been cached, because that's us the time. Then there is got first response byte, which is one of the last events that occurs in the request response lifecycle, because this represents the first byte of data that has been read and received by the client from the server. There are some other information, some other functions that we're not going to go into details because are specifically for whenever the server returns 100 as a status code, which is quite rare. Then there is DNS start, DNS done. So whenever we do DNS lookups, this is going to be quite interesting if, for example, we want to troubleshoot issues with our requests, and we want to know why certain requests are very slow, or why certain requests take fails for some reason. Then you can drill down and see if they're failing at the DNS level, if they're failing afterwards, if they're taking too much time for DNS resolution, and so on and so forth. After the DNS resolution is done, the connect start happen, and this is what happens when, for example, we're attempting to we already know the IP address, and we're attempting to create a TCP connection with that IP address. When that connection is created, the connect.done is going to be invoked, so we know whenever the connection is created. The TLS handshake events are invoked specifically when we are working with HTTPS, and those are useful as well to know if certain steps are taking a long time. And wrote header field, or more specifically wrote headers and wrote body, wrote response. Wrote headers and wrote response are useful for us to know whenever we write some of the data, write all of the data, the request data and the request data and the headers data into the connection, for them then to be sent into the server and wait for the response. So those are right before, those two are right before the last event, which is the got first response byte. So we are going to implement an example so that it's clearer for you, and the example is going to be a client. As you can see here, it's just a request into the example.com website, and we are going to attempt and trace down all the events that happen whenever we send a request. So as I said already, in order to trace the events, we just need to create a context that contains the trace information. But before that, we need to create a trace information, which is the httptrace.client trace struct. And in this struct, as we've just seen, there are all a bunch of functions that you have to implement. GetCon is what is going to be invoked as a first thing ever. So it's just to say we're just attempting to retrieve the connection either from a collection cache, or either we are starting from scratch. Get connection. And I think this takes a string, this returns a string actually. So here we have a address, port and host, I think. Host and port, you can just double check that. This is something we have seen already, trace, client trace. And this is the first one, getCon, and takes host and a port. Then there is, in terms of when it's executed, afterwards it would be the DNS start if you are using a domain name. If you're using an IP address, this won't happen at all. The DNS start will have some information around the DNS start info, so the information around the host. So I'll just call this info, httptrace, DNS start info. And then we are going to do the same, found printf, DNS start. So it's going to tell us whenever we started the DNS lookup, info, and then DNS done. And DNS done, again, is a function that also has an info, this time httptrace DNS done info instead of start info. And you will see in a moment how this will play out. So whenever we issue our request, you will see that all of those methods will be called and the output will be displayed on standard output. So in terms of the timing, just right after that, I think there will be connect start and connect done. So connect start and connect done are going to be the creation of the TCP connection, and it's going to be something that happens all the time, basically each time, unless you reuse the connection, but it happens each time, even if there is no DNS, because you need to create the connection. And this takes the network and the address in which you are attempting to create the TCP connection over. So you just want to printf this, connect start, and we have the address and the network, and then address, actually network and address, and then connect done is going to be consequently similar, network and address, an error as well. So you just need to double check the signatures there, but the usage is pretty similar for each of those. So you know that there is going to be a function that is invoked on a specific event, and that you can just effectively use the signatures there to find out what the usage is and the values are. An error, I guess, if the connection fails. Now at this point you could have got connection as an event. So we have the first event, which is get connection, just about to start the connection. Then we do the DNS lookups. Then we do the connection start and connection done. Then we say got connection. We finally got the connection, and the got connection was here defined the top, which was con.info, get con.info. So we just need to define here info httptrace get con.info found printf got con, and here we just print the info just for illustration purposes. And then one of the other information I think that is interesting to see for us is the response bytes, which is I think the last one which I think is interesting to see. There is also the other ones. You can see put idle con as well, which is interesting to see. But apart from that, the other one that I think it's interesting for us is the get first response bytes. So whenever we get the first bytes as a response, got first response byte. So it's got first response bytes, byte function, void function, and we can say found printf got first response byte, and then we can just go on the next line, put idle connection. This is going to tell us whenever the client is has an intention to reuse this specific connection. So it's going to put, this is going to tell us whenever the connection is being put into a cache, into a connection pool. And it's just a put idle con that as an error, as an argument here. So this is just for us to see whether we are using the connection or not. Put idle con, and then we have our error, and we can just specify it here, error. So this is pretty much the definition of our trace. There are, as you've seen, there are some other hooks that we can define. We are not going to go defining all of them because it's just the same, it's just tedious to do that, but it's interesting to see all of the events that happen. And now, once we have the trace defined, what we can do, we can just say, I want to create a new context with the trace attached to it, and then I want to pass the context into my request. So the creation of context from the trace is with client trace. If you check the documentation from the HTTP trace package, creating the context, so I'll just add some comments in the code so it's easier whenever you have a look at the code. So the first step is create trace info. The second step is then create trace context. So we have ctx, we have HTTP trace with client trace, and we have a request context, which is from our request or background context, is up to what you have already. And then we have our trace, and then attach trace context to request. And how can we attach a trace context to request? Well, there is a go doc http request with context method that you can use already, and with context method you can just create a new request. That's the context that you pass in. Or if you're creating a new request from scratch, you can do new with context, and that will allow you from the HTTP new request with context, that will allow you to create a request given a specific context. We already have a request here, so it's up to you there if you want to use the method or the other, but what I'm going to do is request with context here, and we are going to pass the context. So once we have updated our request, once we have updated our trace context, we have created the trace information here, basically the definition of what we are going to do with all of the trace events. We define the trace context, we attach the trace context to the request, and then we execute the request. And we also need to import all of the dependencies if we have any dependencies here. So I guess we need to do something like the HTTP trace, which is directly into the HTTP package, and the font package as well. And I think that should be it. Get connection info. Con info. Should be got con info, I think. And here we have some information now finally. So request to example.com, as you can see here on the bottom, we can just enlarge this. So we have request to example.com. The first thing that happens is the get connection. So the client is telling us it's about to create or get a new connection from the pool for the host example.com and for the port 80. The DNS resolution starts, so we attempt to find out what the IP address is for this specific host. The DNS resolution ends, and we found out the IP address, and also the IPv6 address here it looks like. Then the connection starts, means that we are opening up a TCP connection directly with the host, with this IP address that we just found out. The TCP connection just been created at this point, and there is no error, as you can see, it's nil. Then it says got connection, so it finally got the connection. It also gives us some information about the connection, whether it was reused, was idle, if it's already present in the pool or not. And then got first response byte as a last event. So this is going to tell us all the events. Now, in terms of put idle connection, this actually didn't happen. And it didn't happen for a specific reason. And the reason why it didn't happen is because of the way that we are using the response. And for the HTTP client to reuse the connection, we need to read the entire body, and we also need to close the body, such that the data is not going to be then, it's not stale data that's going to be used by a subsequent HTTP request. And this can be found specifically in the HTTP response package. If you look at one of the documentation area here, you will see that at some point, just right in the body documentation, we have the default HTTP clients transport may not reuse HTTP keep alive TCP connections if the body is not read to completion and closed. So the reusage of the TCP connection is not going to occur if we don't read the body. We're going to do that in a moment. I just want to lay out the HTTP request response. So what happened here is that we have a DNS request and response based on the events, then what happens is that TCP create connection, okay, using the IP address from the DNS request response. Then we write some data to the TCP connection. Then we read some data from TCP connection, and the read is exactly first byte response means we are reading from the connection, and we are writing whenever we are sending the connection through. And the events, in terms of events, for example, this can be so for example, if you go here, DNS response, the event can be DNS done, DNS start, connect start, for example, mapping those to request response and events, trace events. So just conceptually, and connect done is whenever we connect start and connect done is whenever we got the connection. Write to the TCP connection is the wrote headers, for example, wrote headers which we haven't used, and wrote request. And then it's going to be got first response byte. So these are all the events that happen. Okay. Now, before doing all of the logic to reuse the connection, let's try another connection. Let's try to send another HTTP request and see what happens. So the other example is, as we said here, we are going to do another request. I'm just going to paste this information here, request to example.com. So we finally got the first one, we got the first one in, and we got all of the events. Then we got request to example.com is the second one, and then we got exactly the same data. In this case, we should have reused the connection, but as I said, as you see here, it's reused, it's false, so it's not reusing the connection. So what's happening in there is that for the other HTTP requests, all of those steps are going to go through. So the first step is the DNS request, the DNS response, create the TCP connection, write to the TCP connection, read the TCP connection, and then it's going to be close TCP connection. Whenever we do another request, everything starts from scratch. So we need to do DNS request, DNS response, TCP creation of the connection, write, read, and close the TCP connection. But with HTTP persistent connections, what happens is the following: is the same logic that we see here, but the difference is that instead of doing all of this, the first three steps are going to be effectively something like if TCP connection already exists, do not use it. Basically, use it if it already exists. So this is the logic with the persistent connection. And here is going to be keep connection alive for later use. And this is going to be boot idle connection. So it's going to invoke the boot idle connection event whenever we plan to use the connection again, whenever we are using HTTP persistent connections. So looks like in our example we are not using persistent connection, and to force the client to use the persistent connections, we need to read the body and close the body. So here we have the response, and let's try to do that, and let's try to read the body, and at least in this case you just discard all the items from the body. So you use a util discard and do rest of body discard, and then we can do rest of body dot close. So this is going to allow us to read all of the body and discard the body. Discard, at least read the whole body and close, so that the connection, the underlying TCP connection is reused. And I think this should do the job. So if we just do go run main.go and we see what happens now, we see that the second request is much different than the first one. So we see that the first connection is just all of the steps: get connection, DNS, connection start, connection done, get connection, first response byte, and then put idle connection. Now finally we got the put idle connection. And then get connection, the second example is just get connection is basically getting a connection from a cached state. We got the connection, which was on idle for 218 microseconds, and then we got the first response byte just right after that. And that's a confirmation on why the httptrace package is useful, because it allows us to see all of the events happening on a specific request response. So you can not only do troubleshooting, but you can also do monitoring of performance of each of those steps. For example, if you want to do monitoring of performance, you can just say that you have time t0, for example, and you have time.now, time.now for t0, then you have time for each of those events. We're just going to do a few of them, so we're just going to do getCon, DNS start, DNS done. Then we are going to do getCon and got first response byte, getCon and got first res byte, which are all time.time. So now if we want to measure the time for all of those, we can just say, for example, getCon is equal to time.now, and then here we can print out the time. For example, we can do milliseconds, we can do getCon subtract t0 and see how much time it elapses since t0, milliseconds, and we can do the same for all of the others. We're just going to do for a few of them, obviously, and then you can do it for on your own with others, for the others examples. And then here is DNS start, subtract t0, milliseconds, and similarly DNS done, time.now, and it's going to be milliseconds, and it's going to be DNS done sub t0, milliseconds. Connection, I think getCon is one of the others, and got first response byte. So it's getCon is time.now, and then it's going to be milliseconds, and then getCon.sub t0, milliseconds. And this is going to allow us to see how long each step takes and which are the steps that take the longest. But you're going to see in a moment, first res byte, which one are the slowest ones. And then you can already guess which one are the slowest ones, at least which one is the slowest one. Got first response byte, sub t0, milliseconds. And then obviously after, since we do the HTTP request twice, we'll need to reset the t0 each time we do a request. So it's probably best to define t0 here and say time.now, and before each request we do t0 equal time.now. So it's an accurate measurement. Probably see if we need to do go imports. Go import the time, and we do go main.go. So now we're gonna see that our example with get connection, it starts right away, so it's less than 1 millisecond. The DNS start less than 1 millisecond. The DNS lookups takes 1 millisecond, so finding out the IP address from the domain name takes 1 millisecond. Connect start, we're not tracking the time for that, but for creating the connection it takes 51 milliseconds from the 1 millisecond, so it takes quite some time to talk to the server and establish a connection. And then to send over the data and receive the data back, it takes 83 milliseconds, so it takes 30 milliseconds after the 50 milliseconds. And then you can see that it's pretty consistent. So from the reused connection. In total, this one takes only 37 milliseconds reusing the connection, instead of, for example, creating it from scratch, which would take 83 milliseconds. So almost a third if you reuse the same TCP connection. So you know that establishing a connection, a TCP connection, takes roughly what is it? Is it like 2/3 of the time to establish the TCP connection? 50% of the time, 2/3 of the time, 60% of the time, and you can save that time if you reuse the connection. So the keep alive header is kept on by default on the Go client, so it's something that just you need to be aware of whenever you want to reuse HTTP connections. And this happens when you're talking to the same host and port, obviously. If you're talking to a different port or a different host, you cannot really reuse the same TCP connection, because the TCP connection is just it is just a connection from your host to a given host to a given port. It's just a process and a file descriptor that's open for a given port and a host. So if the post or the host is different, you cannot really reuse it, you need a new one. But you can see that where the performance lies on. So it's pretty much that's pretty much the analysis that you can do. You can build up some statistics tool that can do analysis on the HTTP requests. You can do some troubleshooting as well. If your requests are being reused or not, you can do some troubleshooting on whenever the requests are failing or which steps are failing. And those are the nice things that you can do with the httptrace package. I think it's quite interesting. I think that's all from today, and thanks for watching, and see you on the next one. Thank you.